Professor Vidyasagar is SARB National Chair and Distinguished Professor at IIT Hyderabad, but he's had a long and distinguished career in both the public and private sector in India and abroad. He's basically a control theorist and computer scientist who's worked in various areas of computer science, artificial intelligence, and so on. He was the director of the Center for Artificial Intelligence Research in Bangalore for 10 years. He's also been at TCS Hyderabad, I think Hyderabad. He's been at University of Texas Austin and various places. He's a fellow of the Royal Society and many other awards. Today he's talking about a topic that's really caught the public interest in the last 2 or 3 years, generative AI, and how the public and private sides of India can come together on it. So without further ado, yeah.
So I would like to thank the organizers of this symposium for inviting me to speak here. Originally, I was planning to talk about some technical subject, and then I was told that I should speak about this subject because it's kind of timely. So I will try to talk about this. Certainly much easier to talk about generative AI in half an hour than about any mathematical talk. Now, I knew about Professor Ramakrishna even when I was a PhD student at Wisconsin in the 60s, because right around the time that math science was started in the early 60s, Richard Bellman started this journal called Journal of Mathematical Analysis and Applications. And Professor Ramakrishna was one of the associate editors. Now, back then, for an Indian to be an associate editor of such a prestigious journal was very, very rare. So, I wanted to meet this man, but I never actually had an opportunity. But as it turned out, my father knew him. And so here is a photo. Does this have a pointer? Yeah. So that's my father, Professor M.V. Subbarao. And that's Professor Ramakrishna. Who's the guy in the middle? How many recognize him? Anyway, so actually Krishna is the one who gave me this photo. I didn't have it. So thank you very much for providing this. So I'm going to just, this talk is around 15 slides long. I deliberately made it so that it is about 20 minutes. I was told to make it 25 minutes, but I think on a subject like AI, I'm expecting a lot of questions. However, since this is the first talk after lunch, you may also be looking forward to a welcome nap. So let's see what actually happens. So let's try to nail down the terminology. What is meant by artificial intelligence? And you would have been hearing another phrase, AGI, artificial general intelligence. Okay, what are they? So artificial intelligence, by consensus, is a way of making machines perform tasks that humans found very easy, but earlier machines found very difficult. For example, I'm talking and you're processing the speech in real time. Okay. Until very recently, this was quite difficult for a computer to do. Okay. Similarly, image processing. You see that screen, you know that this is B, that is you, that is I, and so forth. Okay. Or recognizing complex patterns. And so then you can say, okay, that's fine for AI, but what is AGI? So this is something that literally happened in the last 6 to 7 years. So with the advances in both computing power as well as advances in algorithms, there have been specific programs that could perform specific tasks like playing chess or playing Go or doing image recognition, things of this nature. So then people said, why don't we try to figure out one system that does all of these things, at least more than one of those things. So that was called AGI, Artificial General Intelligence. And probably the first step was a program called AlphaZero, which was started by DeepMind, which was a startup then acquired by Google. And they created one program that could simultaneously learn to play chess, Go, and Shugi, which is the Japanese version of chess, And what was very counterintuitive in this paper, and this has not been fully validated yet, but the idea was that prior knowledge doesn't really help a machine to execute its tasks, which is very counterintuitive. So now the third thing I wanted to talk about is the machine learning. So the way I use this phrase machine learning is that it is a set of algorithms that will achieve AI or AGI. I would like to highlight that this is the way in which I use the words. A lot of people use AI and ML synonymously and interchangeably. I try not to do that. I try to say that AI is the destination and ML is the path that will take you towards that destination. Okay? So now, what is generative AI? What is mean by generative? So this is a kind of a quasi-mathematical audience. So I try to make a quick analogy of what is generative AI. So look at this problem. Okay, there is a pointer. So suppose you have some n-dimensional random variable, let me call it x, and you are given samples x1 through xm. You can assume statistically independent to make life simple. And what you want to do is, given these samples, you want to infer the joint probability distribution. Okay? Now, if m is much larger than n, meaning you have a large number of samples in low dimensional space, this is not that difficult. But suppose you invert the situation. You have very few samples, but in a very high dimensional space. So there is no way in which you can actually infer the joint probability distribution. So what do you do then? In generative AI, what you do is you don't even try to infer the joint probability distribution because it's not possible. So instead, you try to pick up a new machine learning algorithm that will create new samples that can fool a human being into thinking that they're coming from the same probability distribution, which is a very different objective because you are not trying to mimic the actual probability distribution, only something that sort of looks like the earlier distribution. So you have these new samples, xm1 plus 1, xm plus 2, and so forth, that are sort of indistinguishable from the data you already have. And now how do you generate these samples? If you have been following the jargon, there is something called prompt engineering. So prompt engineering is just a very clever way of exciting this generative network that will generate these new samples, xm plus 1 and so forth. And these prompts can be either deterministic or random, okay? Now this is very high level. If you want me to go into more details, I'm quite happy to do that, all right? So this is another thing that's very common nowadays, large language models. So what's a large language model? So if you think about a syntactic language, okay, they'll have some rules of grammar. As an extremely crude example, you can say a word X followed by the word Y is illegal. Is legal, pardon me, and X followed by Z is illegal, okay? So if you have a syntactic grammar, and if a person is actually following that grammar, you will never see XZ, but you will see lots of occurrences of XY. So large language models dispense with grammars totally. They just say, we're just going to take a huge set of data and see what follows what, and come up with statistical models. And if indeed the string is coming from a syntactic grammar, which it need not, by the way, but if it is coming from a syntactic grammar, the large language model will learn that XY is fine, XZ is not fine, because it sees lots of occurrences of XY, but it never sees XZ. The advantage of these large language models is that they work even when there is no underlying structure. Okay. So, what's the mathematical problem? Well, here's the mathematical problem. Suppose you have a Markov process. What I'm trying to do here is to say that this is not all madness. There is actually some underlying mathematics to all this. Okay. So suppose you have a Markov process. So what's the Markov process? The conditional probability of the next state depends only on the current state. So you think about a Markov process with memory. So that means the conditional probability of the next state depends on the previous two states, 5 states, 10 states, 20 states, whatever. Now suppose this tail is very long. This is what the large language model people call the context. Context is just the length of the tail. How many steps back do you have to go? And you can kind of see their logic. If you want to understand the meaning of a particular word, it's not enough to look at the preceding word or the preceding 2 words or whatever. You may have to go back 100 words. Okay? Then what you do is, you take all these. So if you have a Markov process with memory n, you look at the collection of n plus 1 tuples and you calculate all the joint probability distribution. Okay? And then, how do you use these large language models to predict the next output? You see the memory and you figure out which is the next state that has the highest likelihood of occurrence, and it comes out. That's the good thing about large language models. It is completely rigorous in a certain sense. Now you can make a refinement. The trouble with this statement was that the second most likely transition is never predicted. Only the most likely transition is predicted. So that doesn't make any sense. So then people do some sort of a randomized approach where you predict the next symbol according to the conditional probability. Okay? And the only way to get a proper large language model is to train it on a large corpus of data, which is representative of what you're trying to do. So for example, if you're trying to teach a computer to write like Jane Austen, you train on a large corpus of Jane Austen novels. There are only 6 of them, but anyway, you do the best you can. Now the point is that the corpus is crucial. So suppose you take ChatGPT, which is the one that's most in the news, okay? And if you ask ChatGPT, what kind of a king was Aurangzeb, okay? Aurangzeb will tell you, the ChatGPT will tell you, Aurangzeb was a great king, he was benevolent, he lived a very simple life, because it has been totally trained on the writings of people like Audrey Truschka. So if you want something that's relevant to India, you have to train it on corpus that is relevant to India. Because once you have the corpus, the rest is absolutely automatic in a mathematical sense. Now you might have heard of this word transformer. So a transformer is a very special type of neural network architecture. And I'm going to go through this very fast because it's kind of a word salad. But what it does is, there are 3 steps. One is encoding, which is to take abstract symbols, convert it into vectors, because that computers can only process vectors of real numbers. Then there's the nonlinear neural network, and then there's the decoder, which converts the real vectors back into the abstract state. They're not very well understood mathematically. Large language models are well understood. These are not. So I see a lot of young people in the back. If you want to do some research, you can work on why transformers work. Or there are alternatives to transformers. These are things you can do. And in ChatGPT, the GPT stands for Generative Pre-trained Transformers. I've told you what generative means. Pre-trained is kind of obvious, just trained on a whole bunch of data. And T is for transformer. So here's a picture, totally unreadable, but I just want to put it up anyway to say that this was the seminal paper by Vaswani and company, who were at Google. And they proposed this architecture. And interestingly, they could have kept it as a company secret, patented it or something, but they gave it away. So now what is the current status? So the first out of the starting gate was ChatGPT from this company called OpenAI. I don't know how many people know the history of OpenAI. One of the early founders of OpenAI was Elon Musk. And he wanted OpenAI to produce, as the name implied, tools for AI that were completely in the public domain. Then some others got a bright idea, and it was registered as a non-profit. Okay. Then somebody had the bright idea, some sharp legal mind, that There is no bar against a non-profit company owning a profitable company. So they created this OpenAI corporation as opposed to the OpenAI Foundation. So this disgusted Musk so much that he resigned. But anyway, they came out with ChatGPT-3, ChatGPT-4, and they're huge. GPT-3 had 275 billion. No. Sorry, apologies. This is not 2.75, that is 275 billion adjustable parameter. And ChatGPT-4 has 1.5 trillion. So these are huge networks. Here's a very important research area. Do we need so many parameters? That is there a way of training a neural network and simplifying it so that functionally it is equivalent? So Google has had a bit of a rough time in this area. They had a series of models, none of it was very satisfactory. They started with something called BARD, and they didn't test it very well. When they had the public launch, it gave a bunch of wrong answers, so it got condemned universally. Then they came out with something called Lambda, and just last week they started something called Gemini. We have to see how well they do, but they don't have much mind share in this area. And third is Meta, which is Facebook. They have something called Llama. And all these are basically the same, LLM something, okay. So now they have released a lot of it in open source. Now the point I want you to notice is the smallest Llama that Meta has released has only 7 billion parameters, okay. Now you think about it, Facebook is not stupid to release a model that is going to be obviously inferior to something that is already in the marketplace. Which means that even with as few as 7 billion parameters, you can get acceptable performance, if not outstanding performance. But again, there is no theory of going down from a large network to a small network. These guys had 7 billion parameters because they started with 7 billion parameters. Okay? Now, there are a few examples you can find on the internet of humans trying to interact with ChatGPT-4, 3 or 4, it doesn't matter. So this was seen as the cat's whiskers, completely human-like interaction. It can do anything and everything. And so you can just type this in any search engine, you'll find more such examples. The first one was, it was asked to factor x squared plus 35x plus 7. Now this doesn't have integer roots, okay? And it basically said it has no roots. So it didn't know about the fundamental theorem of algebra that a second order polynomial has 2 roots, okay? Second one was, this is the more interesting one. This happened only about a month ago. It was asked, I have a water tank and I want to drain it of water. Should I put one pipe with a 1-inch diameter or 2 pipes with half-inch diameter? Okay, all you young people, which should we use? Which drains the water faster? One big tap. Well, we all know that it's obvious because we know that the drainage rate is proportional to the surface area. Okay, but ChatGPT initially said that the 2 pipes of half-inch diameter are better. Then ChatGPT said, no, they're both draining equally fast. And then most interesting is the third bullet. When the user said, no, you're wrong, ChatGPT basically started arguing. So the 2 conclusions, number 1 is ChatGPT is not guaranteed to give correct answers. And I think of it more like an MBA rather than a scientist. It gives completely wrong answers with complete confidence and then defends them if you point out the errors. Okay, so why is ChatGPT so popular? The reason is because its language model is easily the best. The interaction, the sentences that come out are very natural. That doesn't mean they're right, but they sound very human. Okay. Now, there's a lot of research that can be done here, and I've been trying to encourage the Indian scientific community to do some of this work. If somebody is interested, I can describe it, but maybe not now. If you want to ask in Q&A, I'll answer that. So what are the options for India? So where does AI stand in this domain? So if you want to answer this question, you need to figure out the landscape of AI. There's a lot of activity. So I divided somewhat arbitrarily into 4 different categories. First category are companies that create AI products and utilities. So OpenAI, the company, created ChatGPT 1, 2, 3, 4, licensed it to Microsoft for its exclusive use. Okay? If you think you are going to compete with OpenAI, then you can basically forget it. I mean, in India, you can forget it. Second is companies that use AI-based tools to enhance the user experience of their customers. So why is Microsoft interested in ChatGPT? Because they think they can build a better search engine, customer relationship management software. All of these things they want to use the ChatGPT-like tools. Okay. The third category, so all the big companies, Microsoft, Google, Meta, they're all doing this. So therefore, we have no way of breaking into this either. The third one are companies that use AI-based tools to boost their productivity internally. Okay. So in other words, if you are a TCS or a Wipro or an Infosys, can your employees generate code faster? But the key is your code has to be provably correct. Generating code is easy. Generating correct code is much harder. Okay. So that's what these companies are working on now is provably correct output that can boost their productivity. So many of the IT biggies are in this space. And the fourth one is companies that create solutions using AI-based tools for other companies. So if you're a small startup with say 10, 15, 20 people, you can create a solution that you can take to TCS or Infosys and say, you give a specification of a Python code, my tool will produce provably correct Python code. Not plausible looking Python code, but provably correct. This, I think, is the place where we have a lot of area. So as I mentioned already, I think items 1 and 2 are more or less out of the question. 3 is something that I feel Government of India should be doing. They aren't really doing. And the gap here is that Indian language interfaces are a major weakness of all these chat-like tools. What people have done is slapped a kind of Indian language interface on top of a tool developed on English. Now, if you ever use Google Translate for anything serious, you know that it can often produce very hilarious results. Okay, and this bullet is very crucial. I gave you that Aurangzeb example because if you have taken only corpus from Western sources, it will not be very useful. Now, it turns out you can actually take an open source AI model and retrain it on Indian corpus. And it will take less time, less effort, but it will be far better performing on Indian problems. And so I'm saying that I think item 4, building AI solutions for others is where we should be focusing. So the Government of India announced in the budget speech in February of this year that they are going to set up 5 centers of excellence in AI. The request for proposals finally came out, and I put my need to be released in question mark because next year is election year. So by definition, there will be no budget. Request for proposals. Next year is an election year, so Parliament will meet in February and pass a vote on account only. They cannot pass a real budget as per law. So sometime in June, July, there will be a new Parliament. It might be BJP again, it doesn't matter, but they still have to meet and pass a fresh budget. Anyway, so in this RFP, request for proposal, they said we have 3 focus areas: agriculture, healthcare, and sustainable cities. In the first year, they are going to um, fund 2 crores per year for 1 year in 15 proposals. That means in each of the 3 core areas, they're going to choose 5 proposals. And I think there's a typo here. This is not 4 years, this is 3 years. So, at the end of the first year, within each area, these 5 groups will compete against each other. They say they will get 310 crores. That sounds like a lot of money, but you should always read the fine print. This 310 crores is subject to the institution raising 30 crores from private endowment and also creating a corpus of 100 crores. Now, you are in an academic institution, forget about crores, even generating lakhs is not exactly easy. Right? And also the other problem is, okay, first of all, what is the total outlay? The total outlay is 15 into 2 for the first round and 3 into 310, that's 960 crores. That's about $115 million. Over 4 years, that's about less than $30 million per year. We can't be serious. Spending $30 million per year, we're not going to compete with the world. So this is just some eyewash type of a program. I'm sorry to be so blunt. We should be spending close to $1 billion per year if we're at all serious, which we're not. And look at the deliverables. In agriculture, you are supposed to increase the crop yield for millets by 10%. Why millets? Why not rice or whatever? You know that government is pushing millet. And second question is, what does this have to do with AI? Increasing yield of millets, what does that have to do with AI? It's like AI-enabled millet growing system. I mean, come on, it doesn't make any sense. Similar in healthcare, 10% increase in the number of healthy births for 10,000 and so forth. So, I don't think that any fundamental research will come out of this. It's very applied. So, one of the problems in generative AI is that normally when you think about computing, you focus on the cost of computation. So, suppose you want to do computational fluid dynamics, you want to design an airplane. Obviously, you need lots of computation, but you don't need much storage. But in here, you need both computation and storage. So both are very costly. You have petabytes of storage, even if you're a startup. So the other point is that if you want to manipulate these huge data sets, you require specialized skills in data science. And these people are in great demand. And the spelling mistake there, great demand. And they command very high salaries. So it's not clear where we'll get the money for that. So how do we do this? So I think that this is my recipe. You start with open source software and then tweak it for Indian data. And what the center should do, there is a lot of Indian corpus, but it's highly scattered, not searchable. Suppose you want to say something like, has someone digitized Kalidasa's Meghadutam? Okay, they want to train a Sanskrit language tool. There's no place where you can ask this question and get a reliable answer. That's what I mean by a centralized corpus. And though it's available, it's highly scattered. A lot of the skills are in software, so we're good at software. And some of the required computing resources can be cloud-based. So what are the challenges? So mostly Indian venture capitalists are not venturesome at all. Okay, that's the main problem. And second one is that the students, like all of you sitting in the back, you generally don't have access to large computing platform. If you know how to run something on a laptop or even a server or a workstation, that doesn't scale to a server. So we need places where people can just play with these kinds of computing tools. I hope that the Indian private sector will surprise anyone. Okay, well, I made a mistake. I thought I would take 20 minutes. I took more than that. But still, if anybody has any comments or questions, at the discretion of the organizers, I can try to answer them.
Thank you very much, Mr. Vidyasagar. And we certainly have time for a few questions, and I'm sure there are some.
Yeah.
So you mentioned that the language capabilities of ChatGPT are what are much better.
Multilingual capability.
So why would you want to solve both the delivery of natural language as well as the other problem, which is arriving at the truth using the same kinds of
Because
platform?
the reach will be very limited if you don't have the Indian language capabilities.
No, I'm not talking about the Indian language capability, but in general, say LLMs, if they are able to deliver understandable natural language, even if they're making statements that are false, the issue of truth and falsehood can be determined using other.
Well, the reason is because the same problem came when browsers like Firefox started trying to display Indian languages. Because our Indian languages are not basically sequential. See, any Markovian model, it says that you have the conditional probability of the next state given the previous. But in the case of Indian languages, you also have a dependence in the opposite direction. Maybe it's very easy to solve, but at least somebody needs to think about this problem.
Anyone else? So I have a question. You mentioned that you don't think India can compete with the Google Meta types on really building
Not at these scales.
right. No, as you said, this whole transformer idea came in 2017 and revolutionized the field. Isn't it conceivable that this is not the best possible architecture? Somebody else comes up with something else where you can actually get away with a much smaller corpus or a much smaller computing setup to get equally good results. And that kind of research, do you think, is feasible in India?
Oh, most certainly. This is the next to last bullet here. They're not that well understood at a mathematical level. See, in the transformer, they use trigonometric functions. Why? Well, nobody knows why. It works, and nobody has had any great incentive to challenge that. Maybe wavelets will work better than trigonometric functions. So, but that's the kind of thing we can do because the resources required are not much. So I'm echoing exactly your sentiment that we should pick those problems where we have a higher likelihood of success. So that's a very good one. The other one I mentioned 2-3 times already in this lecture. Why do you need a trillion parameter model? Suppose somebody has a trillion parameter model. Do you have a systematic theory of distilling it down by a factor of 10 or even 100? There's no theory for that. So these are all things that we can do, I think.
Okay, thank you very much again, Professor Vidyasagar. And we have a small memento for you, I believe.